In this problem, notice we're looking at a situation that has alternate exterior angles. The angles lay outside the parallel lines on either side of the transversal, so therefore they are alternate exterior. Now let's go ahead. I'm going to just highlight these real quick. We're going to do a couple different things. First, I'm going to solve for x, right? Which could be all your paper is asking you to do. You have to read your instructions and see, are you solving for x or solving for the angle? But we're going to do both in this problem. I'm going to solve for x first, and once I find x, I am then going to go ahead and solve for this bottom angle this time. So I'm going to go ahead and highlight it. In other words, I'm going to bold it so that we're finding the bolded angle. So let me go ahead and set this up. Now I know that by definition alternate exterior angles are equivalent. In other words, this angle has to be equal to this angle. So I'm going to go ahead right quick and I'm going to set these up as an equation. I'm going to write my first angle, 13x plus 6 is equal to my second angle, 14x minus 2. And now that I've done that, I'm going to go ahead and draw my line through my equal sign. And let's go ahead and start moving things around. Now remember, we want to move our constant values to the right, and we want to move our variables all over to the left. So I see that this is adding 6 on the left. So I'm going to do the inverse operation, which is to subtract 6, so they cancel. I then have to subtract 6 from the opposing side. And I'm going to put this in my calculator. So I have negative 2 plus negative 6. So negative 2 plus negative 6. Notice it gives me negative 8. So I now have negative 8 for my constant value on the right. And to move this 14x over to the left, it is a positive 14x. So I want to do the inverse operation, which is the opposite, which is subtraction. It cancels my variable on the right. And then I'm going to subtract 14x over here on the left. And if I were to take my calculator and do 13 minus, I should say 13 plus negative 14, and combine those two terms, it leaves me with negative 1. So I then have a negative 1x over on the left. Now we can't have our variable with a negative. We do want it to be a positive. So I need to go ahead and divide out that coefficient of negative 1 on both sides. That gets rid of my negative, because negative 1 divided by negative 1 is positive 1. It just leaves me with x is equal to, and all we're going to have here is a sign change, right? But if you're not good at memorizing the sign changes, just go ahead and put in your fraction bar and do your negative 8 over negative 1. And that gives you positive 8. Now I'm going to circle it. If it said just solve for x, well then you solve for x. And this is your answer. So this could be an answer. If solving for x. Now if that's not your final answer and they said we wanted you to find this bolded angle here, well we got to take that x value and substitute it in place of x in this expression to figure out what it is. So let's go ahead and I'm going to put right here, I'm going to put answer if finding angle. So we're going to try to find this angle. So I'm going to take this 14x minus 2. Now we know what x is, right? We just solved for it and we found that x is simply equal to 8. So since x is simply equal to 8, I'm just going to replace the x with a set of parentheses and I'm going to put an 8 in there. In other words, we are just substituting the value of x into our expression. So 14x minus 2, and if I were to put this all in the calculator, let's put that in there, 14 parenthesis 8 close parenthesis, that means it's just multiplying 14 times 8, and then we're going to subtract 2 from it, and it gives me 110. So this angle right here is 110 degrees. That also means, since these are alternate exterior angles, that this angle is 110 degrees. So by substituting into that expression, we have now found that the angle on either side is 110 degrees. So now let's do a different definition.